Hello and welcome to Xamarin University. And today we're going to look at what's new into iOS 8. So thank you for joining me today for this recording. My name is Adrian Stevens and I'm an instructor at Xamarin University. So you're going to want to make sure that your system is up to date before we get started. And that means if you're working on your Mac, you'll be using Xamarin Studio, and just make sure that you've got your system up to date. Being on the stable or beta channel should be just fine. If you're working on Visual Studio on your Windows PC, please do make sure you have Visual Studio 2013 with at least Update 2 installed. And at the time of this recording, Update 3 is definitely recommended. As well, do make sure you download the course materials for this presentation today. You should be able to get those from university.xamarin.com. And there's some really great example code that you're going to want to use to follow along with some of the demos and labs today. So a lot has been updated in iOS 8. And so with that, we're going to explore some of the major new features of Apple's new mobile operating system. And then specifically, I want to look at some of the UIKit API changes. They've made some updates, added some new APIs, and we're going to explore those in detail. And then finally, I want to talk about what's really possibly the most exciting update to iOS 8. And that's the unified storyboards. So we'll take a little look at how we can use those and how it's integrated with the Xamarin Studio Designer. So with our first objective, let's explore some of the new features of iOS 8 from a higher level. And with that, we're going to explore the new frameworks, of course, see some of the API differences from previous versions of iOS. And we're talking about a new feature, something that's new to us for developers, and that's app extensions. And then I want to take a look at how iOS is now more tightly integrated with OS X if you own both pieces of hardware. So iOS 8 is, as the slide said, a massive update. iOS 8 represents the largest surface change to the APIs and tools since Apple opened up the APIs to let her build applications way back with the iPhone 3. So we just simply can't cover everything today. But I do want to cover the highlights, and we'll provide some further details on specific aspects in other courses. And so with that, I want to reduce all of the changes down to two big categories. I want to discuss how our apps can connect or hook into the operating system. And with that, this gives us a bit more flexibility as developers and really, in a way, brings it more in line with other more flexible, more open platforms that we've been used to developing on. And then second, I want to look at writing UI code that is adaptive or reactive, if you will. And by that I mean UI code that can dynamically take advantage of the available screen space we have to draw to. So let's look at some of the new APIs from a high level. First, Touch ID. So we can now use Touch ID to authenticate a user before accessing some or all the content within our apps. And this is, of course, our local authentication. This is the fingerprint scanner. And it's important to note the fingerprint data is protected. It's never accessed by iOS or other apps. So it is a very secure method to protect data within your applications, or at least act as a gateway into your application. We have HomeKit. Now, this is the new framework, and I think a lot of people have heard a lot about this. This is the new framework for identifying and controlling connected devices in the home. So it's going to have discovery, control, and management, and it allows for some really interesting applications. Things like integrating your apps with Siri. So you could ask Siri, for example, to adjust the temperature in your room or turn the lights on. HealthKit. This allows apps to provide health and fitness services to access shared health-related content, all in one place. Now, what's really fantastic about HealthKit, the information is centrally stored and it's user-controlled. That means the user The user owns that information. And then apps can access, i.e. they can read and they can write, to shared fitness or health information as allowed by the user. And then of course is also going to integrate, with system sensors on your devices, as well as connected devices. Of course, Bluetooth LE becoming a big deal here as well, allowing us to connect to external devices and tie that into the HealthKit API. PhotoKit, another big change and almost a surprise to some of us as developers. Apple's provided new APIs now for working with photo and video assets, but these are assets that are owned by the built-in Photos application. So we can now edit photos directly in the camera roll. We no longer need to import them into our application and keep things in sync. We can read and write directly to the photo content, and we can monitor changes made by other apps and respond to those changes within our own application. We also have CloudKit. This is going to allow us to easily and securely store and retrieve our app data, things like structured data in a database or other assets right from iCloud. This is going to do things like allow us to authenticate with our apps using iCloud credentials. Of course, no passwords are going to be shared, so it'll provide authentication. We can access private and public databases, as well as doing structured or asset storage services. And finally, the AV Foundation or camera APIs. So these frameworks give apps direct control over the camera hardware. And by that, I mean the camera focus. We can control the white balance and the exposure settings. Also supports things like bracketed exposure captures. We can automatically capture images with different exposure settings. Pretty fantastic. A whole new level of control and interaction with the hardware and iOS. Pretty exciting. There's also been a big focus on gaming with iOS 8. Games, of course, are the largest category of apps in the App Store, and iOS 8 adds 3 new frameworks to support easier creation of both 2D and 3D games. First, I want to talk about SpriteKit. And SpriteKit provides a 2D animation infrastructure. So you can use this to animate textured images, commonly referred to as sprites. And this was part of iOS 7, but it got a lot of new really great features in iOS 8. It now has support for light sources and shadows. You can apply per pixel physics. This is going to make object collisions and interactions very realistic. Of course, we do that based on their shape, based on the pixels. We also have inverse kinematics. This allows for realistic joint movement in our characters and our objects. Next, I want to talk about SceneKit. And SceneKit is a 3D rendering framework. And this combines a high-performance rendering engine with a high-level descriptive API used to create 3D animated scenes and effects. And it incorporates a physics engine again for realistic movement. We have a particle generator, so you can do things like realistic explosions, or fog, or smoke. We have easy ways to script the actions of 3D objects, so we can describe our scenes in terms of its content. Geometry, materials, lights, and cameras, and then animate it by describing changes in those objects over time. And then the engine itself can simulate things like gravity, forces, rigid body collisions, and joints. And as well, it will also integrate with SpriteKit, so we can include 2D animation assets in 3D games. Pretty fantastic for overlays, menus, or just a different point of view within your 3D game. And then if all that isn't flexible enough for you, we have Metal. And Metal provides a low-level API for GPU accelerated, with the A7 chips, for GPU accelerated 3D graphics. And this is the low level, this is the hardcore gaming engine, if you will. It's similar to OpenGLS, but of course it's not cross-platform, it is iOS specific. And it's designed to be extremely efficient with Apple hardware. So it's going to offer much improved speed and low overhead compared to using OpenGLES. It also supports APIs to access the GPU for calculations. And so this can be used independent of your gaming code. So we can write applications that can run parallel algorithms directly on the A7 chip. And again, this is hardcore, but not from a gaming point of view. It could allow for some very CPU powerful applications. Now, many of the existing frameworks got a lot of improvements as well. And I want to give you just a couple of examples. So in core image, some new image detectors were added. So prior to iOS 8, we only had facial detection, supported in CI detection APIs. Now has support for barcodes, and that's within both photos and on the camera. As well, it can detect rectangular regions, again in photos or from the camera. Core image also now has support for GPU level image filters. Now these are written in GLSL, and this means that we can write custom image filters and run them directly on the GPU for image processing. Do keep in mind though, iOS has, I believe, about 115 filters included already, but if you do need to go beyond the stock 115 filters, you can write your own. There's new audio video features added. These are for game and audio manipulation. As well, Apple announced Apple Pay and NFC support for the iPhone 6, and these APIs came in iOS 8.1. Now, one of the largest changes to iOS 8 is extensibility. We can now hook into the operating system features in ways that were not possible before, short of jailbreaking our device. And I'm going to walk through all of these one by one. We've got a new document picker that allows us to reach outside of our application and interact with files not stored within our local sandbox. I mentioned some photo editing. We're going to look a bit deeper on that, but we can now interact with photos stored on the device without having to import them into our local application space first. We have some improved means of file sharing with AirDrop. We can write custom keyboards. Those are the soft input panels, the keyboards that come on screen. We're able to add custom keyboards and install them on the device to be used with other applications. Some big changes in the notification center, and with that we can write custom actions, as well as some changes with storage providers. Simply put, we can now write custom storage providers and save to them within our application without having to know intimate details on the storage provider's APIs. And again, we'll explore that in just a few minutes. So I want to first talk about creating extensions. So Xamarin already has support in our framework for building extensions in C#. So we have new project types. These are available in Xamarin Studio and Visual Studio. Keep in mind though, it's only supported in the 64-bit unified API. And hopefully you've seen that in the templates already. We have that unified API section. That's where you're going to find the extension project templates. Now historically, our application has been limited to its own app sandbox. With that I mean it can write to the file system and load files, save files, but only within folders within a sandbox specific for our application. We're not able to reach beyond our own folder structure. We're effectively isolated from other applications. And we would only be able to reach outside of that using system APIs to read or write data. We now have the document picker included in iOS. And this is extendable with custom storage providers. Now, of course, we have iCloud. That's included out of the box. But for example, Dropbox can include their own storage provider. And then we could read and possibly write documents to the user's Dropbox, but we wouldn't need to code against the Dropbox API. Dropbox would set that storage provider, and we would just access that from the document picker. Now let's talk a little bit about app-to-app communication. And this has always been a bit tricky in iOS. Now in iOS 7, things got a little bit easier. They introduced the share sheet. This is to push information between known applications, primarily used by applications supplied by Apple themselves. Now, iOS 8 opens this up to custom apps at 2 levels. We can take content from our application and share it with other applications directly. And so in this case, the system copies the content to a location, and the other app can access and manage the transfer of data. Or we can create an action, which is a function to perform on the data. So examples would be printing, playing, displaying. And the key benefits to this is that we're able to connect applications together, but we do this in a loosely coupled fashion. And this means the applications don't need to have knowledge of each other, but can still pass the information back and forth. I mentioned this earlier, we can create custom keyboards. Could do something like a swipe keyboard and use that to replace the system keyboard for use within other applications. Now there are some restrictions. Anytime a user is entering a password, they will always use the system keyboard. This is of course done for security. We're not able to write custom keyboards for entering phone numbers. We're not able to copy or paste data to and from the application from a custom keyboard. And also keep in mind that applications are able to opt out of using third-party keyboards and force the system keyboard to be used. And one thing I want to mention, custom keyboards are able to access the network. So you could use these for things like predictive text, to reach out to a web service, maybe look up spelling. Now this is disabled by default, and again, for security reasons. But as a keyboard developer, you are able to turn on network access. Now, the Notification Center got a big overhaul in iOS 8 and now supports custom widgets on the Today screen. So this allows for custom interactive content to be placed on the Today page, and this is going to provide the user with specialized content that they're specifically interested in. And our slide here is a fantastic example. Notice we have Sports Center, and we obviously have a baseball fan. We've got some baseball scores. So content that the user is interested in as an individual. And also, you're going to see later on, we can now associate actions with notifications. And this allows the user to interact and respond to notifications without needing to open the application. So using a simple API and foundation, your app can now participate in handoff to let users start an activity on one device and seamlessly resume the activity on another device. These are the new continuity features. Now, the example Apple loves to show off is receiving a phone call while working on your Mac. And the caller ID information shows up on the Mac and can be answered there. This does require Bluetooth LE, so you'll need newer devices. Most iOS devices will work with this. Anything that runs iOS 8 will be compatible, of course. And any Macs developed in the last, released in the last 4 years or so should be safe. Now keep in mind it is possible that the carrier may restrict some of this capability. For example, to keep people from pushing the call over to voice or IP, depending on the carrier's specific goals and requirements. I'm going to open up the resources we downloaded for our class today. So I'm in my lab materials folder. Open up part 1 resources, demos, Photo Explorer. And we'll look at our Photo Explorer application. Go ahead and open this up in Visual Studio or in Xamarin Studio. Once you have it loaded, go ahead and start the application. And this app is going to show off some of the new APIs we have for photo manipulation in iOS 8. And if you've ever done photo imports to access the content from the default Photos app, this is really going to excite you. Really streamline the process. So right away, Photo Explorer is going to ask for permission to access the photos, because we're going to interact with the default photos. We're going to interact directly with that photo cache. Let's hit OK. And these are the photos that are on an iOS device by default. And that was very fast. It was very quick. And we can interact with these photos, and they're just being displayed in a simple collection view. Now let's click on the first one. I think it's a great looking photo. And you can see here we can load it. But I want to click the Apply Effect button. You see the photo has now changed to black and white, and we get a pop-up asking if we would like to allow the Photo Explorer application to modify this photo. And if I hit modify, all right, it's black and white. I go back to my photo list, and we see here it is also showing in black and white. But what I want to show you is if I go to the Photos application on my device, this photo has been changed. This has been edited. It is now in black and white. We've applied that effect directly to the photos stored in the Photos application. Again, if you've done this on older versions of iOS, you'll find this very exciting. So let's take a look at the code. I want to open up the Photos View controller. Note, as I mentioned, it's just a UI collection view controller. I won't go into all of the details of interacting with the collection view. And again, we do have some excellent classes on that at Xamarin University. But I do want to point you out to a couple of variables we have, a couple class level variables at the top. We have what we call a photo library observer. It's a very descriptive name. We'll use this to observe changes in the photo library. And we have a PH image manager, a photo image manager. This is going to allow us to interact with that photo image cache. So look at our constructor. We're going to new up the PH image manager. And then we're going to call a static method called fetch assets against the photo asset class, the PH asset class. And fetch assets is designed just to return generic results, and we're going to specify that we would like images. And this is going to give us a connection to the stored images on the device. And then finally, remember our photo library observer. Well, we're going to new this up. We're going to make an instance of it, save it off, of course, and we're going to pass it in to another static method we call against PH photo library, our shared photo library, and then we want to register change observer. Simply put, we want to get notified when changes are made to the photo library on the device. Now I want to scroll back up and show you our property here, our PH fetch result. And so it's a public property. And we'll have a local version we'll save off. And then we'll also have our setter. And all we're going to do with this is anytime we set it, anytime we change a result, add a result, we're going to update our collection view. This is a nice shortcut just to keep our UI in sync with our data collection. Now, what I really want to show you is the getCell method. Again, it's just a collection view, and this is the method that's responsible for returning the individual cells for our collection view. So now we're going to use our image manager. We're going to call request image for asset. And we're going to call this against those PH fetch results that we got earlier in our constructor. We're going to pass in the index from our NS index path. And this is going to allow us to get an actual UI image to be displayed within our cell. And this is how we're visualizing the contents from that photo collection, from our default photo app. And then also note here, in item selected, we're going to implement navigation. We're going to push our view controller, and we're going to go to our photo view controller. And this is where we're actually going to apply the filter. We'll actually convert our image to black and white. And the last thing I want to point out here is our photo library observer class. And we use this to watch for changes in the photo library. And again, keep our UI in sync. So let's now open up our photo view controller. And note that we're passing in, in our photo view controller, we're setting the asset. We're passing in the PH asset, or specifically a reference to the image that we want to display and edit. So open up photo view controller. You note here our public PH asset, again a reference to our photo. And we have an on apply filter method. And simply put, this is called, when we click on our right bar button item, i.e. that button on our navigation controller UI. And this is going to apply the filter. And there's a few things I want to point out. The first thing we do is we call request content editing input against our asset. And simply put, we're saying, hey, I would like permission to edit this asset. And again, as the user will allow or disallow that. And then we've got some example code here, and we're applying a CI photo effect noir. And you can see the code here, excellent example. You can walk through it and see the individual steps to edit and save the photo. Keep in mind there are a number of other photo effects you can use that are built in to iOS 8. But what I really want to show you here is perform changes against our shared photo library. Again, a static method. And we're going to request the ability to save, to edit to the photo library. And again, we saw that pop up. And if the user allows it, this is going to push the changes back to the photo library. I want to now move to a second demo. Also in our demos folder, and we're going to open up the Touch ID test. Now, unfortunately, I don't have a Touch ID enabled device in front of me, but as well, I am demoing on the screen, so it'll be a little bit harder to show you. But I can walk you through the code, and fortunately, it's actually relatively easy to implement. So again, I'm going to run this project first, give you a sense of what the UI looks like. And this is a test project. It's a very simple UI. And the idea is we're going to use local authentication, or simply put, we're going to allow a user to access specific content in the application by using the fingerprint scanner. And most of the work we want to look at today is in the AuthView controller code. And we'll just open that up while our project is building. And I'll point out now, it is just a simple UI view controller. And again, it's a very simple application. And so we've got our view controller contained in a navigation controller, and I'm going to push Authenticate. And you can see here I'm getting a pop-up, biometrics not supported. And that's not surprising, of course, we're on a simulator and I would have no way to actually touch the device. There's no fingerprint scanner for my simulator on my Mac. So let's close this down. If we look at the app delegate, you can see here we're actually using a storyboard. And in the storyboard, I won't go through the steps now of opening it, but we do have our view controller contained within a navigation view controller. And we have a button, and we'll handle touch up inside and connect that to perform authentication. And the first thing we do is new up an LA context object. It stands for local authentication. And then we're just going to check, can we evaluate the policy device owner authentication with biometrics? And I will show you, it is currently the only policy we have available. This may be an indication that Apple is exploring other possibilities. At this point, I don't know. But currently, this is the only type of authentication we can do. And look at that API. I want to pause here for a moment too. This is important. So this is going to restrict access to content within our application, assuming the user is able to pass. And if the user is able to authenticate using biometrics by touching the touch sensor, they're able to go forward. Is device owner authentication. And this is authenticating against the owner of the phone. iPhones, iPads are typically meant for the most part as single user devices. Of course, they are shared. But when it comes to securing data, personal data, they are meant as single user devices. So this is not meant to authenticate your entire company, for example, into an application. It's meant to ensure that only the owner of the device is able to access this content. And so we check can evaluate policy. And simply put, this is really asking, hey, is the hardware available to do biometric authentication? And if we can, Then we're going to wire up an LA context reply handler. This is simply, is the biometric authentication positive or negative? Has it gone through? And you can see here we're checking is it successful, and then we're going to perform a segue. We're going to navigate to a new section in our application. Otherwise, we're going to show an alert controller saying, hey, you're not allowed to go forward. And so to actually implement the policy, to actually authenticate the user, we call evaluate policy against our LA context, our local authentication context. And again, we specify the policy. Again, we only have one type. And you can see here, by running this, a reply will come into this code here. And so simply put, there's really only 3 things we have to do. We check if we're able to use biometric authentication, we evaluate the policy, and we handle the reply. And you can see this little bit of code here is just what we saw running, another alert controller, simply telling us that we don't have biometric support on our device. A very powerful, really great way of adding some security to data within your application. We'll talk a little bit more about this in other classes, but the fingerprint data is stored in the secure enclave on the device. And what that means is that it's stored in hardware security on iOS. As well, the fingerprint data is not stored in its entirety. It's effectively like hashing your fingerprint data. So it stores enough information to compare against a local authentication, but not enough to duplicate your fingerprint scan. It would be very, very difficult for these devices to be hacked, but if it was possible, someone did hack and retrieve the fingerprint data, it would not be enough to use to do authentication into other applications. So very secure, and it's an excellent way of adding a level of security to your sensitive data within your application. So we got a great overview of some of the new and updated frameworks we have at our disposal as iOS 8 developers. We learned a bit about app extensions, integration with OS X, local authentication, lots of great things to play with. Let's now go forward and see some of the changes in UIKit. And with that, some of the new controls we have and some of the updates to existing controls. And so UIKit is the framework that we use to create and display user interface elements in iOS. So every API that starts with UI is part of UIKit. So obviously it's a big and important framework to us as developers. And with that, we have a number of tasks we want to cover today. We're going to see some changes in existing controls. We're going to see some improvements in navigation, new ways of alerting the user and providing modal content, and streamlining some of the old existing APIs like the search bar. And finally, we'll look at some visualization techniques we can add just to add a little bit of polish or flair to our applications, if you will. So prior to iOS 8, we used several different APIs to display alerts to the user. And the 2 most common were the UI AlertView, and this is for message box style alerts, and the UI action sheet, which was used for interactive prompts, and that would really give you more choices, more selection for the user. Now, iOS 8 is really all about adaptive design, or making the best use of the physical screen space we have on individual device. And so to that end, iOS 8 now deprecates both of these functions, and they've been replaced with a single unified API. And it's actually able to show both of these visual styles and several others as well. So I'd like to introduce you to the UI Alert Controller. And the UI Alert Controller is functionally identical. It's a block-based replacement for both UI AlertView and UI Action Sheet. So switching between an alert or an action sheet is done with this API simply by setting the preferred style when creating the controller. So to show an alert, we instantiate the controller through a factory method, simply called create. Now there is no delegate, So instead, we're going to supply the title, description, and alert style. And this is what's going to choose between the alert and action sheet styles. And then we can add action buttons by creating an instance of UI alert action, which you then add to the controller. Now the UI alert action consists of a title, style, and a callback, which gets executed when the user selects the action. Now there's 3 possible choices for the UI alert action style. We have default, cancel, and destructive. Now keep in mind, the display order for your buttons depends on the order that they're added to the alert controller. And you should always follow the iOS human interface guidelines when creating your alert controller pop-ups. Your default action should always be the rightmost button. The cancel button should always be the left button if you're doing a simple 2-button alert. And you can only have one cancel button, as you would expect, but if you do add a second, you'll get a runtime exception. We also have the ability to add text fields. We actually have more than one. We can include a password field in here as well. So we can add these to our alerts. Keep in mind only to the alerts, not to the action sheets. And we do that using the add text field set of methods. And here you can see we're using the default style for a single OK button. Now, in the interest of screen real estate and our physical screen space, the navigation controller has some new properties to control the visibility of the navigation bar. And this is a very common thing I've heard developers talk about and ask about. Really great to see the API improvements here. We can now hide it on swipe or tap, or when the keyboard appears. We can hide it when an iPhone is in landscape orientation, or when the view is pushed onto the navigation stack. And all we do is simply set the appropriate property. And you can see that right here on our slide. Enable hides bar on tap, and it's going to hide it on tap or on swipe. Pretty fantastic, great descriptive APIs here. Now when working with the master detail views, the view controllers need to be aware of the owning navigation controller to push new views onto the stack. And that makes sense. But unfortunately, this knowledge requires fairly tight coupling of our view controllers to the structure of the UI. And simply put, that means that when we're creating individual view controllers, individual screens, we typically had to code them to the UI architecture of our application. And that meant, in some cases, custom UI code for each application, a little bit less easy for us to reuse this UI code. And it also often meant writing idiom-specific code. So for things like dealing with a split view controller on the iPad versus a regular navigation controller on the iPhone, we're doing a lot of custom coding and a lot of branching. So iOS 8, things are changing, and Apple no longer recommends using the push view controller method that we've gotten used to on our UI navigation controller. But instead, it's introduced 2 new adaptive methods on the UI view controller class. Now the first method is the ShowViewController method. And it takes a child controller and a sender, and that's often going to be the parent controller. And this method will walk up the view hierarchy. It's going to identify the parent navigation controller and then push the child onto the navigation stack. So effectively, that's going to behave just like the push view controller. However, the method is on the base view controller, and we don't require any knowledge about the parent navigation controller. We don't have to interact with that navigation controller property anymore. And even better, if the parent isn't a nav controller, but it's a split view controller, well then this method will still work, and it's just going to replace the master view, or the left side view, of our split view. And if there's no navigation controller, or no split view controller, the child gets displayed through a modal push. So this method's going to work in all 3 cases automatically without any code change. Now the second method is the show detail view controller. And this is primarily intended for the detailed view of a split view. Now this again will walk up, locate the parent split view controller, and then replace the right-hand side view, i.e. the details pane, with a specified controller. If there's no split view, but instead a navigation controller, then this method pushes the child onto the navigation stack, again, doing the right thing based on the current UI configuration. And this is great for a lot of reasons. It's great for more abstract development where we can create view controllers that will implement navigation, but they can be brought into multiple view controllers, allowing us to change our navigation style. And it also means it becomes a lot more flexible when dealing with multiple device types. Another adaptive UI element added into iOS 8 is support for popovers. And this is done through a new Popover Presenter Controller class. So when you present a popover on a tablet, i.e. an iPad, it gets displayed as a proper true popover. And you can see that on our slide here. We've got our arrow and our placement over a specific area. But when we present it on an iPhone, it does a modal push. You can see it displays the content full screen on the phone, making what's effectively the best use of the physical screen space. Now it turns out we don't create the popover controller ourselves. Instead, we simply set the modal presentation style property on any view controller. And this signals your desire to display this as a popover element. So when you present the view controller, as you'll see here, iOS will create the popover control automatically when the content is displayed on a tablet. Now we can customize this pop-up on a tablet. We do that through the Popover Presentation Controller property on the view controller that you're about to present. And this returns a UI Popover Presentation Controller object. Now you want to make sure you do this before calling Present View Controller. It's important to remember to check for null here as well. This property is only going to be set if the view was presented as a pop-up. And so for today, that means on an iPad. And so once you have access to it, you can set the view that it's going to obscure, the direction of the arrow, and the UI element to orient the arrow onto, as you can see here in our code fragment. Now another interesting thing Apple has done is replace the UI search display controller. And perhaps it's about time. This has actually been around since iOS 3. And it's been replaced with a new search controller that dramatically simplifies adding search support with live results into our applications. So our new UI search controller has 3 pieces of information it coordinates. It creates a UI search bar. It does this for you and exposes it through a read-only property. Now you create a custom view controller to display the search results. And this is often a table view, but you can use any UI you like, and then you pass the view controller to the constructor of the UI search controller. Now you implement a new class which acts as a mediator between the search controller search bar and search results. And as the user types into the search bar, this new search results updater is now responsible for refreshing the results in your custom view controller. Now you can implement this however you like, and in the lab exercise coming up, you're going to use an event to connect the 2 pieces together. Now here's an example of this class. So to create a search results updater, we derive a class from UI search results updating, and then override the update search results for search controller. That's a mouthful. An instance of this class is assigned to the search results updater property of the UI search controller. Now this method is called on each keystroke change in the search bar and should make any updates necessary to your search results as you're typing. Let's change directions now and talk about notifications. So again, notifications, they got some improvements. They got some love here in iOS 8. First thing, the max payload size got bumped up from 256 bytes to 2000 bytes. Now there's the more subtle changes involving security and interaction with notification displays. So our notifications come in two types. We have silent and UI. Now, silent push notifications are ones which tell your app to update information. So these present no UI to the user. So UI notifications are the ones that we typically think of as push notifications, right? They're alerts, they're badges, and sounds. So iOS 8 separates these into two categories, and it auto accepts silent notifications now. So this means that our apps can much more reliably depend on receiving silent push notifications. They've also made some changes to the UI style notifications as well. So in the past, there was no way for an app to know about the types of notifications allowed without trying it. So users would have the ability to turn them on and off, and they could do that on a per app basis. But our apps would have no ability to discover this without going ahead and trying the notification and then seeing if it failed. So in iOS 8, they've added a new discovery mechanism where your app can register the notifications it would like to use through a UI user notification settings object. Now these include all styles, so any visible or audible alerts in conjunction with a local or push notification that your app employs. UIKit then correlates the information that you provide with the user's preferences to determine what types of alerts your app is going to be allowed to employ and notifies your application so it can optimize how it communicates with the user. And so with this, you may want to let your users know that your app is going to work best when they allow notifications. All right, so the first step in this process is to let UIKit know what types of notifications that you'd like to utilize. And so in this case, we're going to say alerts and badges. And this is normally done at app startup in your app delegate. And that's exactly what we see here. We're going to create our UI user notification type. Then we're going to call get settings for types, get that UI user notification settings object, and then simply put, we register the settings. And we're going to call that static register user notification settings method call with our derived settings. So UIKit then interacts with this and with the allowed notification styles and calls new method did register user notification settings, another big one. And this tells your app what is allowed. And so application code can now react accordingly and then possibly use other forms of notification or prompt the user, go, hey, you know what? I actually work a lot better with notifications. Do you mind turning that on? Might be a good strategy depending on how you've architected your code or how important those notifications are to you. Now, another new notification feature is the ability to register custom actions with a notification, which the user can then interact with on the notification screen or when the notification occurs. So actions provide custom buttons that users can use when interacting with your push notification. So your action can launch the app into the foreground or even trigger a background action, such as accepting or declining a calendar invite. Now here you can see a custom set of actions revealed on the lock screen. We do that by swiping the notification. And you have similar touch responses for banners where you can pull them down to reveal actions, which can be performed directly to the notification without the user having to switch out of the app that they're currently in or even unlock the device. Now to enable this feature, we'll define a user notification category with the identifier string, and then a map of UI user notification action context. We do that to many UI user notification actions, which is established through the set actions method. And again, note that is plural set actions. Now, a UI user notification action context comes in two flavors. We have default and minimal. The default context specifies which actions should be presented when the notification has an alert UI and supports a maximum of 4 actions. So the minimal context, this specifies which actions should be presented when the notification has a banner UI or is on the lock screen, and it supports a maximum of 2 actions. So once you've registered a notification categories with your application, you can then send them with remote notifications. So you pass the category identifier as the category option in your push, then override the new UI application delegate handle action method, which is going to receive the category as part of that remote notification. One last thing I want to talk about. Finally, now in iOS 8, it opens up the API that they use for the blur effects. Now, this was added back in iOS 7, and we'd see it used fairly heavily on things like our navigation bars when our view controllers were scrolling, passing underneath them. So we can now utilize these visual effects in our own applications. It's a great way to provide a sense of depth and overlay when creating our own customized pop-ups or overlays. And we do this through the new UI Visual Effects class. Now the primary one is the blur effect, and it has a few styles. We can do extra light, light, and dark, and this controls how the obscured view is colored. Now to add it into a view, we create the blur effect and then add it into the scene through the new UI Visual Effect view. And we set that frame appropriately, and then anything under the view will then be blurred out. And then the second effect, the UI Vibrancy effect, this can be used to make a portion of the blurred image pop, if you will, and that just brightens the colors. Keep in mind, this effect can only be used with the blur effect. It cannot be used on its own. Now, believe it or not, there are a lot more of other changes to UIKit to make our lives as developers easier. And you'll see some of these in the lab exercise. Collection views and table views are now able to auto-size their cells. So this means we no longer need to write a bunch of resize code as our content changes or need to manage differently sized cells. It's a really big improvement. Saves a lot of hassle and a lot of time. I also want to mention the iPhone now supports the split view controller. And this makes it really the go-to container for master detail views. And I wouldn't even bother with a traditional navigation controller, especially for building a universal app. So the split view controller, when used on the iPhone, is going to collapse down and act like a navigation controller. And then it'll open up and react like a normal split view controller on an iPad. That means we use one code base for both device idioms, and it's going to behave appropriately and make excellent use of the available screen size. We also have several new picker controllers. Includes one to select a printer from within your app. Pretty fantastic. And there's a lot more. But we'll take a break from the slides, and it's time for you now to write some code. And with that, you're going to move on to an individual exercise, and you'll get a chance to work with some of the new features. So let's head back over to our downloaded content, our class materials. Let's open up the Start Here HTML document. And like many of our classes, we've got an overview, expected duration. And of course, I always like to point out, you have a link here to a PDF version of the slides that I'm using, We are covering a lot of content today. That's a really great resource for you to use later. And I'm going to have you work on exercise number 2. And you're going to work with some of those new UIKit changes. So please go ahead and click on the exercise link. It should take you approximately 20 minutes. I'm going to ask you to pause the video as you work through the lab. Take as much time as you need, and then we'll do a review. Just resume the video. But first, let's look at the content. Again, approximately 20 minutes. You're going to need to make sure your system is up to date. You're going to need the iOS 8 SDK installed. This comes along with Xcode 6. We're now up to Xcode 6.1. And again, it's always a good idea to keep your development tools fairly up to date. And I will mention again, do make sure that your Xamarin tools are also up to date. You don't need to be on alpha, and I don't recommend it. Stable or beta will be absolutely fine for this exercise. And you're going to start with an existing project. It's a checkbook application. And, well, I'm not going to give it all away. You get to play with a lot of new features of iOS 8. You're going to take this application and you're going to modify it. You're going to improve it. Really exciting. We use those dynamic table views, some of the new navigation bar features. And so with that, I'm just going to ask you to go ahead and start. And again, we'll review once you've completed the exercise. So for now, please start on exercise number 2 and pause the video. So I'll go back to our lab materials, our downloaded course content. In the Part 1 resources folder, Lab Complete, let's open up that version of the checkbook solution. Let's just run it. Let's see the completed project. Now you made quite a few changes. Now you explored that dynamic cell sizing. You handled swipe and added custom actions. And of course we see our real-time search working very nicely as well. Most of that work was done in the checkbook view controller. Of course, you implemented the search results, and with that, you added the research results updater, and you made use of the search results view controller that was included for you in the project. Wired up a UI search controller, added it to your UI. As well, you explored the dynamic cell sizing available in iOS 8. You saw that the default cell style will respond to system font changes and automatically adjust its height according to the content. But you also saw that custom cells will do that as well, as long as that automatic dimension property is set. And finally, you saw that you can handle swipe and add custom actions. We did that by overriding edit actions for row. And again, you've got a ton of really great sample code here. So if you have any problems or any issues, definitely compare your project to the final project. So we covered quite a bit. We talked about the new ways of presenting alerts to the user, navigation controller condensing. So with that, we'll use the split view controller now and use that as our go-to control now for master detailer navigation. Of course, it collapses down to behave like a traditional navigation controller on iOS. It opens up to the split view. We talked about the new features of popover elements. You saw how to manage the search bar. We talked about custom effects and notifications. Really covered a lot of content. Definitely remember all this content is here for review. And don't be afraid to go back through the slides. There is a lot of content. And if you do need to go deeper on any of these topics, don't be afraid to post questions on the forums or schedule one-on-one time with an instructor. So let's move forward to our third objective. In our final section, we're going to look at one of what I think is one of the coolest, most interesting features added into iOS 8. And that's unified storyboards. So the unified storyboards are going to allow us to effectively create one UI to work across all iOS 8 compatible devices. And with that, we're going to explore some new concepts. We'll look at size classes, and with that, traits, and then we'll take a brief tour of the Xamarin Designer and see how we're able to create universal dynamic UIs using the unified storyboards using the Xamarin Designer. So, way back in 2007, of course, the iPhone was released, and in 2008, we were given the App Store. And life for a developer was pretty good. It was pretty easy. We only had one physical screen size to worry about. We did have two orientations, but even back then, we could probably get away with just making portrait applications. We could effectively make one UI, maybe two. And it was pretty easy. We could make pixel-perfect UIs, great-looking applications. But then Apple started to bring out additional devices and additional screen sizes. And of course, we got the iPad and the iPhone 5. Now we have the iPhone 6 and 6 Plus. And so today, we're not only dealing with a lot of different physical screen sizes, but different pixel densities as well. We have Retina displays, we have HD displays, we have iPods in different physical sizes. And there's possibly more devices coming around the corner. There's the Apple Watch. There's been rumors of a larger iPad. And so we can no longer just independently design screens for each form factor. We need to start thinking about ways of making reactive or adaptive UIs. Now, there were some solutions to this problem back in iOS 7 and really iOS 6. So in iOS 6.1, Apple introduced the concept of auto layout with constraints. And if you're not familiar with auto layout and constraints, simply put, it allows us to size and position our views relative to one another, as opposed to just hard-coding positions and widths and heights. And so this allowed us to create adaptive UIs, so they could dynamically take advantage of the available screen real estate and then resize or reposition based on the device size, type, and orientation. Now, this only partially solved the problem because we still needed to create separate storyboards for the iPhone and the iPad, and that meant duplicating a lot of work. So in iOS 8, we now have unified storyboards, and they're the final piece of the puzzle for creating a truly flexible UI. So with unified storyboards, we again can create one UI. We create one storyboard for our application, and then we're going to leverage auto layout and constraints, and we'll use those to manage the differences between devices instead of coding unique UIs for each device size and type. So this all sounds great, but how does it work? So when we create our UI, we've always been interested in two factors for our screen design. So we think about what type of device we're using, and that's known as the idiom. Is it a phone? Is it a tablet? And then what orientation is the device in? And we needed these two pieces of information because these are the real world factors that drove our layout. But that's not really the question we should be asking. And what we really want to know is, how much space do we have to display our UI? How much room do I have to draw my controls? And this should be the question driving our UI design going forward with iOS 8. And so with that, Apple has introduced a new UI concept that's called size classes. Now this quote comes right from the Apple documentation. Size classes for iOS 8 enable designing a single universal storyboard with customized layouts for both iPhone and iPad. And with size classes, we can define common views and constraints once and then add variations for each supported form factor. And so the size classes are really Apple's solution to that question of, how am I going to work with all these different device screen sizes and orientations? So with size classes, we can now define our screen space in a known, generic way without relying on idiom and orientation directly. But instead, we're going to let the operating system worry about that, and we'll have it just tell us in a higher level terms really what we can draw to. How much space do we have? So this new concept effectively deprecates the UI interface orientation and UI user interface idiom. So we're not going to use those any longer going forward with iOS 8. Now before we dive into the details, I do want to pause for a moment and just make sure that we all understand when we would use this new feature, and just as importantly, when we wouldn't. So size classes with unified storyboards are fantastic if you want your application to look and feel the same on all the different device variations. And this is probably going to be true for most of your applications, especially business apps. However, if you want your apps to have a different look and feel as the user goes from the phone to the tablet, you're not likely going to use this new feature. Instead, just continue to create your UI as you always have, with separate storyboards, or possibly code, to describe the UI specific to the device style. It's also important to note this feature only works in iOS 8. So of course, if you do need to support older devices or older versions of iOS, you're not going to be able to use size classes and universal storyboards. So let's talk about these size classes. We have two types in iOS 8. We have regular and compact. Now the regular size class denotes either a large amount of screen space, so such as an iPad, or a commonly adopted paradigm that provides the illusion of a large amount of screen space. And a good example of that is vertical scrolling on an iPhone. And we'll talk about that a little bit more in just a couple of minutes. Now, a compact size class indicates a smaller amount of real estate. So for example, an iPhone in the landscape orientation, where we don't have much vertical space up and down, that would be compact. Now, every iOS device we have is defined by a set of size classes in two dimensions, vertical and horizontal. And those two size classes are independent. So we could have a device with a size class that's regular in the vertical dimension, but compact in the horizontal dimension, or could be regular in both dimensions. And that's a good example of an iPad, which has a large amount of space both horizontally and vertically. So let's map these size classes and dimensions to the devices that we have available. Now, this diagram comes from Apple's documentation, and it shows how the two size classes and the two dimensions are meshed together and how they apply to our current iPhone and iPad devices. And presumably the same matrix is going to apply to new devices when Apple releases them, possibly things like the Apple Watch or the new larger iPad, if it is released. Now, the important thing to keep in mind here is that every device will have a horizontal and vertical size class, and together these define the set of layout attributes, which are then going to decide what to show on the screen. So let's look at this information in a more graphical way, and we'll look at it from the device perspective. Now, because of the larger screen space, the iPad uses the regular size class in both the vertical and horizontal dimensions. Now, an example I like to use for size classes is consuming web content, looking at a web page. And I think about an iPad and I hold it in portrait orientation. And it's got a nice physically large screen. And it's very comfortable to view web pages. So I'm holding it in portrait and there's enough width for me to see the entire width of most pages. And if it has to scale a little bit, it's still nice and large, and it's very comfortable and easy for me to consume and view web content. As well, in portrait, top to bottom, there's lots of space. So I can see lots of content, and again, it's very comfortable. Now I turn my iPad to landscape. Well, of course, width, there's lots of width for my content. And again, that's a very comfortable way to view web content, but there's still plenty of height. So again, in portrait or landscape, the iPad is comfortable in both dimensions. And so it's actually considered regular regardless of orientation in both dimensions. And so our size classes don't change when we rotate the device. Now we go to an iPhone. Now the iPhone has different size classes based on the orientation of the device. So in portrait, the screen has a compact size horizontally and a regular size vertically. And let's pause and think about this for a moment. So again, I'm going to go back to the example of the web page. Now, no one would argue that it's quite narrow going left to right on our width. And that's considered a compact width. Now, of course, using the example of web content, yes, we can browse web content fairly easily on an iPhone, and we might be very used to it, but we find we often have to zoom in, or some content is off screen, we have to pan it. And it's not quite as smooth, quite as easy as it is on an iPad. It's a restricted width, and we have ways of dealing with it, but it's not an ideal experience. Now, when your device is in portrait, and you're looking at web content, well, there's a good amount of height. It's not a bad size screen, but it's not a lot of space. But what Apple has decided is that a very common UI paradigm of scrolling vertically on iOS. So it's very natural, very easy, and very intuitive to scroll our screen up and down. So even though the iPhone isn't necessarily a large device vertically up and down, it's very easy to get to more vertical content. So Apple by default actually considers the iPhone in portrait to have a regular size class in its height on portrait. Now turn your device to landscape. Now, going back to that idea of scrolling content, well, yes, we can still scroll up and down, but the screen is so small that even scrolling content makes that a very restrictive experience. And so landscape vertically, that's compact. Now, you might think that by turning our phone to landscape, that the width would now become regular because we can scroll back and forth. But we don't scroll left to right as often on iOS, so we don't consider that a regular UI paradigm of scrolling. We don't scroll horizontally as often. It's not quite as natural, quite not as intuitive. So we consider the iPhone a compact width. Now, I'm going to throw one more thing into the mix now. With the iPhone 6 Plus, it has a larger 5.5-inch screen. And just to make things a little bit more interesting, Apple actually considers that largest iPhone to have a regular size class in the width when in landscape. Now that might be confusing, but the lesson here is to stop thinking about the devices and start thinking about the size classes. And if we code and respond to size classes, design our UI to interact and respond and display content based off those size classes, then we don't have to memorize which device is in which size class and which orientation. We just code to these size classes and make our UI dynamic. So how do we do this? Well, how do we define our UI for different size classes? So we need to introduce a new topic called traits. And traits are properties that we use to determine how the layout of our application should change as its environment changes. And this includes several pieces of information. We have a size class in the horizontal dimension and a size class in the vertical dimension. So actually our size classes are considered traits. Then we have two more traits. We have a device type or an idiom, and that's just phone versus tablet. But depending on our application, we don't want to rely on the idiom as heavily, especially comparing something like an iPad mini to an iPhone 6 Plus. The lines are beginning to blur between the phone and the tablet in terms of physical screen space, but it's going to depend on your specific application needs. And then the fourth one is the display scale. And this used to be just our regular devices versus our Retina. We now have an at 3x for the iPhone 6 Plus or our HD screen. Now these four pieces of information together, these four traits are held as a group in a trait collection. And iOS uses the trait collection to then decide how to lay out and display our UI. And the layout rules are all done described using constraints. So this means if you're not using auto layout and constraints today, you're going to want to start to take advantage of this feature. And additionally, the system is going to automatically manage images for you if you put them in an asset catalog. And this means we don't need to use that traditional loose file concept with the @2x naming convention anymore. We can bundle images into the asset catalog, and it will automatically pull out the correct image based on the traits. All right, so how does this all translate to UI? Okay, well first, the OS maintains a trait collection for each UI component that makes up your scene. That starts with the UI screen. And then that goes through to the window, our UI view controller, and then finally to our individual controls, the actual views that make up our UI. Now traits can be combined and passed from parent to child. And so at the end, we end up with a fully qualified trait collection. And what that means is that all 4 values are set, and these are needed to determine what our final UI should look like. Now we have new overrides on our views and our view controllers, these are on the base classes, that are going to allow us to interact with this process. So these allow us to change the decisions applied and therefore change the UI based on some details in our code. So for example, I told you the split view controller collapses the detail view into the master view and acts like a normal navigation controller on the iPhone. However, we can override the traits, perhaps when in landscape would make the most sense. So in the landscape orientation, we can force the horizontal dimension to a regular size class, where it's by default on a phone, a compact size class. And when we do that, it's actually going to show the split view controller with that master detail, that split plane view on an iPhone. For UI design, trait collections mean thinking less about the specific device you're designing for, and instead thinking about the attributes of that device. So we no longer want to design for pixel sizes. And that's traditionally how iOS apps have been laid out. It's just not practical anymore as we move into all these various screen sizes. And think about the iPhone alone. We've got the iPhone 4S, 5 series, 6 and 6 Plus, all with different screen sizes and resolutions. So instead, the goal should be thinking about designing in the general sense for the class of device, or possibly even more abstractly as well. But presently, a good place to start is thinking about a landscape phone and a portrait phone, but not those devices specifically to specific variations of the iPhone, but just as a phone in general, and as well with the tablet in landscape and portrait mode. Now, depending on the complexity of your UI, this can actually be abstracted even further. You can think of a more generic iOS device and not differentiate between phones and tablets. Now with that, we're going to handle variations in size using constraints. And so in that way, the UI will be correct on an iPhone 4 with a small screen, as well as an iPhone 6 Plus with his larger 5.5-inch screen, or possibly even all the way up to the iPad as well. And we'll use the relationships, the auto layout and constraints to dynamically size and align our content. So to enable this sort of design, Xamarin has updated the iOS designer to support size classes. However, it's needed to be explicitly enabled through the toolbar. And do keep in mind that once you turn this feature on, the storyboard will require iOS 8 and Xcode 6 or higher. You should also make sure that your app is universal. And if you start with the universal template, you'll delete the extra storyboard. Now we can work with traits and constraints and our size classes all in code, but it's not that pleasant. There are times you will go to the code behind, but for the most part, you're going to want to use them in the designer. So if you've avoided moving to the designer and the storyboard approach so far, now is really the time to jump on board and get up to speed using the Xamarin designer. So, with our trait variations defined in our storyboard design, or possibly in code, The OS is then at runtime going to select the appropriate constraints to apply based on that trait collection that it retrieves from the scene. Again, remember, this is a combination of all the players, all the views and controls that present the view from the screen to those individual controls or views. Now, traits can also be used for things like image assets, as we mentioned earlier, assuming that you're using asset catalogs. And instead of having 1x, 2x, and 3x versions of your assets, you can specify different image assets for horizontal and vertical compact size class, as well as say one for horizontal regular or vertical compact. Basically, we can include different assets for different traits and size classes. Now our code, it will still look like the same UI image call. We'll still use UI image from file, UI image from bundle, and the asset catalog will take care of rendering the appropriate image. So it's going to pull out the correct image based on our current traits. We can also request specific images with known characteristics through a new image asset API. So let's switch over to Xamarin Studio or Visual Studio, try out the new designer, and see how we can enable universal storyboards. So I'll make a new solution. In the iOS templates, let's expand this, and let's make an iPhone single view application. Yes, we are going to make a project that works across all of our iOS 8 devices, but currently the universal templates, the templates that support both iPhone and iPad, will create separate storyboards for both device types. So I'll make an iPhone application. It'll only make one storyboard, and then we'll change the project settings to be compatible with the iPad as well. So give it a name and create your project. Once it's ready, right-click on the project options, go to under Build, iOS Application, and where it says Devices, let's change this to Universal. So again, of course, it'll support our iPhone and iPads. And note, the deployment target is set to 8.0. That's where it should be. By using the universal storyboards, our projects will no longer work on older versions of iOS. We will only support iOS 8 and up. Hit OK. And now let's open our storyboard. And as we would expect from creating an iPhone application, we see an iPhone View controller. And note up top, View As, we're now able to select different iPhone models and see how our UI is going to look on these devices. Do keep in mind, this is just a visualization. This is not changing our storyboard. It's only how we're able to see it on the designer. So if you notice on the right-hand side, our properties under widget, we have a checkbox that says use size classes. So we can check this, or under view as, select enable size classes. When we do this, we'll get a pop-up, effectively a warning saying it's going to update our storyboard format. So we'll enable auto layout and lets us know this is not going to work with older versions of our tools or Xcode 5. So our warning, let's enable size classes. And note right away our design surface changes. This is now effectively a representation of any iOS device. This is our generic design surface. This is actually a 600 by 600 square, as you can see, design surface. And we'll use this to create our UI in the most abstract, generic way possible. And then we can still do some further customizations for the individual platforms. So note the view as still works. So I can still go back to my 5S and see what my UI is going to look like. And I can also go to iPad as well. Let's go back to generic. Let's just add, I'm going to add just a UI view. It's that view base class. Let's bring this in. And I'll give it a background color. And this is just a nice simple way of visualizing how our size classes are going to work with our controls. This, of course, could be a button or a label or a more complex control. But our nice green rectangle works very well here. So now you can see I can go to other views. You can see that it's now disappeared on the iPhone. It's off screen. And I go to the iPad. There it is. So on the iPad, I could decide that this is not an ideal placement, and I can open this up. And if I go back to generic, note what happens. It hasn't updated the position here on our generic view, only on the iPad view. But I've noticed it's off screen on the iPhone. So if I go back to generic, let's just move this over to the left-hand side. Now it's on screen. I could actually customize this for my iPhone 4S. Generic stays the same. And the iPad is still maintaining its settings. And so what we can do is we can lay out our UI using the generic design surface and then customize it for the individual devices. But we're not actually customizing it specifically for the iPhone 4S as it looks like. We're actually customizing it for size classes. So I want you to note in the top left-hand corner, this is actually specifying a compact width and a regular height. And we're just visualizing it as an iPhone 4S, but we're actually customizing it for those size classes. And just the same with the iPad. I'm customizing it for the regular width, regular height size class. And what you'll note here too, I change the orientation, those same position and size settings are maintained. It's still a regular width, regular height size class in landscape on the iPad, and it's not ideally positioned. If I were to go ahead and drag this out, it would actually maintain this change when I go back to portrait, and you'll note that it's now cut off. Now, the way we would make this work across different orientations and across the different variations of our iPhone is we would use dynamic layouts. We would use constraints. So I would likely turn on constraints. I might constrain this to the left edge. And constrain this to the right edge. And then adjust those constraints so it fits properly. And we will have some classes coming out very soon that are going to talk about auto layout and constraints, and then go a bit deeper, of course, into our universal storyboards. I'm going to leave it here for now. But what I do want to show you, though, you have seen, of course, that it is changing our size classes as we change our views. So if I click up top, we now see our any width, our any height size class. This is actually our generic size class. And now we get our size class matrix. And this again comes from Apple. And this follows Apple's design guidelines on how to lay out our UI. We have our size class matrix. And by selecting the middle, this is actually the any width, any height. And this is our most generic view, our generic mode for laying out our UI. And then we can go to more specific size class settings. So for example, I can go to the lower left-hand corner, select a compact width, regular height, which for now represents our iPhones in portrait. Or I can explicitly specify a regular width and regular height for our iPads. And we can now make, and you can see here it's actually changed over to the settings that I use for the iPad. Don't worry about the red exclamation marks. I need to tidy up my constraints. Let's remove those for now. But this allows us to create our UI in the most generic way possible with our any, and then we can fine-tune position, sizes, and even turn views on and off for the individual size classes. So let's look at these designer size classes a little bit more carefully. And I want this to help you see on this grid how these designer maps correlate to specific devices. So by default, we want to start in our base configuration. That's the center, our any width, any height. So think of this as your master interface. So then things set up and changed here are going to be used for your iPhone, for your iPad. It's going to work on all orientations for all devices. And now, of course, Apple recommends doing most of your interface work here in this configuration. And that's simply because it's going to mean less work for you. And then once the base UI is defined, you can make changes based on the variations you want to support. And there are effectively 4 things we can change. We can change the constraints, we can change the positions, we can change the fonts, and as well we can turn constraints or subviews on and off. So it does give us a lot of flexibility, but we still want to do as much work as we possibly can from the generic sense, and then we'll customize for the specific traits, specific size classes. So with that, we covered quite a bit, but in a way we've only scratched the surface. So we saw why we'd like to use unified storyboards. And effectively it almost brings us back to 2008. And we only had one device to design for. We can now design for a generic device and have our UI, through auto layouts and constraints, take advantage of all the different physical dimensions and resolutions. And with that, we learned all about the device classes, the size classes, as well as how that reflects to traits. And then we saw how to use the Xamarin Designer to create an application using unified storyboards. And again, we will have additional iOS classes that are going to go much deeper into these topics. For now, if you would like to learn more, there is some excellent documentation on developer.xamarin.com. You can look for what's new in iOS 8 and look up unified storyboards. So thank you very much for joining me for iOS 350 and exploring what's new in iOS 8. And if you have further questions, please don't hesitate to reach out to the Xamarin University instructors, ask questions on the forums, or book one-on-one office sessions with the Xamarin University instructor.